Good morning, 11th class. Today we will study about atomic spectra of hydrogen. Now, actually, in earlier video we have learned about spectrum. It's an emission spectrum and absorption spectrum. Okay, now, how that spectrum leads to the development of atomic structure. ये लोग आज हम लोग पढ़ने वाले हैं. Okay, that one is कि how that spectrum is helpful. As I told you that the spectrum of each atom, yeah, either you can say each element is unique, and with the help of this, okay, mostly in chemistry, or either you can say that one is very helpful in finding the element, because the spectrum is totally different. And how to see the spectrum? Simple, with the help of spectroscope, that we will study in higher classes. Okay, now so in case of एटॉमिक स्पेक्ट्रा, तो फर्स्ट ऑफ ऑल रिगार्डिंग टू डेवलपमेंट ऑफ एटॉमिक स्ट्रक्चर, ओके, तो फर्स्ट जो भी इनमें सबसे पहले जितनी भी चीज़ें हुई थी वो दैट वन इज़ ओनली, या जो भी एक्सपेरिमेंट्स थे, ओके, दैट वन इज़ ऑन हाइड्रोजन, बिकॉज हाइड्रोजन इज़ द अर्लीस्ट एलिमेंट जो सबसे पहले इन्हें मिला था. ओके, तो हाइड्रोजन, तो इट्स लाइक सिंपल थिंग कि जैसे घर में जो सबसे पहला बच्चा होता है ना, ओके, तो सब उस पर क्या करने लग जाते हैं, दैट वन इज़ कि अकॉर्डिंगली उस पर अपना प्यार वो करते हैं या समथिंग है. तो सेम कंडीशन इज़ द अर्लीस्ट एलिमेंट. तो जो भी साइंटिस्ट थे, they have performed their experiments and their other things, या theories and all on that. ठीक है, तो that's why, तो first that one we have, that is atomic spectra of hydrogen. Okay, now regarding to atomic spectra of hydrogen, फर्स्ट थिंग इज इसके स्पेक्ट्रम में, स्पेशली एमिशन स्पेक्ट्रम पे किसने काम किया था सबसे पहले? दैट वाज बाल्मर. हमारे पास बाल्मर नाम के साइंटिस्ट थे. ओके, दैट वन इज ही परफॉर्म्ड समथिंग, और आइदर यू कैन से उन्होंने क्या करा था, दैट स्टडीड एमिशन स्पेक्ट्रम ऑफ सम वेवलेंथ. उन्होंने कुछ वेवलेंथ की एमिशन स्पेक्ट्रम को स्टडी किया, एंड आफ्टर स्टडिंग दैट थिंग ही कंक्लूडेड कि उसमें इसने क्या दिया था, एक हमें इक्वेशन दे दी, सिंपल थिंग, for deriving that emission spectrum, and that one, with the help of that we can calculate wave number. तो उसको calculate करने के लिए इसने क्या किया, that one is one simple equation is given to you, that one is nu bar, it's a wave number. Either you can write 1 upon lambda, that is equal to 109,677 centimeter inverse. This one is a constant value, simple, it's a constant value given to you, upon 1 upon 2 square minus 1 upon n square, where this n is integer but higher than this number. If this one is 2, so this one is 3, 4, 5, 6, 7 and so on. Okay, now with the help of this, okay, this one is very helpful in knowing the structure, that obviously we will study later on when we will study about Bohr model and other thing. Okay, but सबसे पहले हमें सीरीज किसने दिया, that one is regarding to, okay, Balmer. Okay, the first thing is given by Balmer. This one is series, and simple one, this one relation is given, that is nu bar is equal to a constant, after that 1 upon, okay, 2 square upon minus 1 upon n square. Now, but in this one, because he studied very that wave number of very few, or either you can say that one is values of spectrum of very few wavelength, उसने कुछ wavelength का जो spectrum थे उस पे उसने काम किया था, but not all. Okay, and even this relation is not perfect for all the things, या जितनी भी इसके स्पेक्ट्रम थे, जितनी भी इसकी सीरीज लाइन आई थी पूरी, okay, this one is not fit for all. Okay, we have other lines also. Okay, then other lines के लिए different scientists we have, जिन्होंने क्या किया, इनके लिए अलग से क्या दिया, एक simple relation. Now another scientist we have, that one is Lyman. ओके, एंड ऑन दैट बेसिस इन्होंने सीरीज़ को नाम क्या दे दिया, दैट वन इज लाइमन सीरीज, बिकॉज स्पेक्ट्रम के लिए किसने काम किया था, लाइमन ने. नाउ ही ऑल्सो ऑब्जर्व द थिंग, he also observed that spectrum, and on the basis of that he said कि the wave number, जो भी आपका wave number है, that one is again equal to, that is a constant 109,677 centimeter square upon 1 upon 1 square, because in this case the value of wave number is different as comparison to Balmer series. Okay, now just see in this one, as comparison to Balmer series. Okay, so in this 1 square minus 1 upon n square. Now here this n square, it's more than 1, means 2, 3, 4, 5, 6, it's any number. Now after that, another one, after Lyman we have Balmer series, then another Paschen. पाश्चर नाम के साइंटिस्ट थे. He also observed some of the spectrum of different wavelength. Now according to this simple, the value of wave number that is equal to 109677 centimeter inverse upon in bracket में 1 upon 3 square minus 1 upon n square. Again same, this n is more than 3 and so on. Just see bracket series, we have p fund series, and even now in present days, yeah, simple, we have 6 series also, and that series is known as Humphrey series, although it's not given in your book, but we have 6 series also there. That one is Humphrey series. Okay, and for that it's a 1 upon 6 square minus 1 upon n square. But previously, okay, when there was the development of atomic structure, जब सब बता रहे थे, तो simple we scientists found only 5 series. One is Lyman, Balmer, Paschen, bracket, and p fund. But okay, after that we have one scientist, that one is Rydberg. Okay, he gave Rydberg equation after observing all these relation regarding to wave number, how they are calculating the value of wave number for different spectrum, या अलग अलग wavelength की light के लिए क्या कर रहे थे. Okay, they had given us one single expression. Okay, तो on the basis of this, इन सबको conclude करके, that Rydberg gave a single relation, because just see, if you observe this thing, okay, all these things have one thing common, that one is a constant, and even other thing also there is something common. So on this basis Rydberg gave an equation, and that equation is known as Rydberg equation. Now just see, this one is Rydberg equation, and for that we have a simple common formula, that is 1 upon lambda is equal to wave number, or either you can write wave number is equal to 1 upon lambda, it's the same, and that is equal to r. Now here this r is a same constant value those who are given by either Balmer, Lyman, okay, Paschen, p fund, okay, this r. But now here, okay, this r is a constant proper and known as Rydberg constant. Why? अब Rydberg ने दिया है इसको equation को, that's why the name is Rydberg constant, उसने अपने नाम पे दे दिया. Okay, in bracket 1 upon n1 square, okay, for lower value, minus 1 upon n2 square, where n1 and n2 are integers. Okay, now remember one thing, then n2 is always greater than n1, where this r is Rydberg constant and value is same, it's a 109677 centimeter inverse. Okay, and you know this one is, all these are different spectral line in the spectrum of hydrogen atom, that we have done already. That one is Lyman, Balmer, Paschen, bracket, and p fund. Okay, even after Bohr model, then I'll show you that diagram also. Now this one is for Rydberg equation for hydrogen atom. Now another expression he gave, that one is Rydberg equation for hydrogen like ions. Okay, what's the meaning of hydrogen like ions? Means, okay, elements, just see, those who have same number of electron. Now He positive, okay, now after this He positive shows कि in this also number of electron is 1, and in Li2 positive again number of electron is same. So this one is for hydrogen like ions. Other thing is same, nu bar is equal to 1 upon lambda is equal to r, it's a constant, in bracket 1 upon n1 square minus 1 upon n2 square, in bracket that one is a z square, where this z is nuclear charge. Okay, that one is regarding to nucleus. What's the charge on the nucleus? For helium, z is equal to 2, or in simple term you can understand what's the number of proton in that particular ion. So in case of He positive, number of protons, z is equal to 2, and Li2 positive, z is equal to 3. Okay, this one is regarding to your Rydberg equation, that is for hydrogen like ions. Now on this basis we have numericals, that one is also important, and even this series is also important. Now just see, this one is one question, that is, what is the wavelength of light emitted when the electron in hydrogen atom undergoes transition from an energy level with n is equal to 4 to an energy level with n is equal to 2. Okay, now what is the color of the radiation? Okay, first of all you can calculate wavelength, means nu bar is equal to 1 upon lambda. So directly we will start with the 1 upon lambda is equal to r. Okay, now 1 upon n 1 square minus 1 upon n2 square. Now n1 is given 2, n2 is given 4, because n2 is always greater than 1. R value that you have to learn, because we will not give an exam, again question paper, that you have to learn. Now put this values. After solving this, your lambda, just see 1 upon 4, that one is 1 upon 16. After solving this, you have to take LCM. Okay, now 3 upon 16. Okay, now after solving this, your answer is 4.86 into 10 to the power minus 5 centimeter. Okay, thank you.